Hi YouTube, Tim Uckert here. In this video, we're going to cover some simple and compound interest problems. This fits a Common Core standard for Algebra 1. I'll leave a link to that in the description. So let's get started. Jimmy goes to his bank, Jimmy Bank, to invest $1,000 in a savings account that earns 2% simple interest annually. After 3 years, he wants to know how much he will have in his bank account. So the simple interest formula is I equals principal, that's the initial amount you invest, times the rate, that's the interest rate as a decimal, times the time, and that'll give me the interest, and then I'm going to have to add that to the principal to get how much he has in his bank account. Okay, so let's identify a few of these things. So the principal is going to be $1,000. The interest rate as a decimal is 0.02. I do have videos on this channel changing a percent to a decimal. And then the time in years is 3. So we're going to do 1,000 times 0.02 times 3. And that's going to give us $60. And then we're going to add that to the principal. So the total amount that he has after 3 years, we'll call that A, is going to be the initial amount he invested, $1,000, plus the $60. So it's going to be $1,060. Okay, let's go try another one. So Sally invests $3,000 at her bank, Sally Bank. They offer 5% simple interest annually. How much interest will Sally earn after 1 year? So in this case, we're just calculating the interest. So again, interest equals the principal amount times the rate times the time. So the principal amount is $3,000. Times the interest rate as a decimal, 0.05 times 1, and that's going to be $150. And that's it for that one. Okay, so next one. Jimmy invests $2,000 at Johnny Bank, which offers, he's mixing it up, offers 3% interest compounded monthly. So this is compound interest. After 5 years, what will be the total amount Jimmy has at Johnny Bank if he doesn't withdraw or deposit any more money? So the compound interest formula is the total amount in the bank is the principal times 1 plus the interest rate as a decimal divided by, well, they use n, but n is the amount of times it's compounded per year, raised to the n times t power. Okay, so we're probably going to open up a calculator to do this. But anyway, so let's write down what we have. So the principal amount is 2,000. Then we put 1 plus the interest rate as decimal, 0.03. It's compounded monthly, so that's 12 times per year because there's 12 months in a year. And we're raising that to the 12 times 5 power, so that's going to be the 60th power. Okay, so I'm going to open up a tab here and search for Desmos calculator. Desmos graphing calculator, we'll use that. Let me just zoom in here so you can see it nice and big. We're just going to use this cell right here. So let's see, what are our amounts? So we have 2,000, 0.3, and 12 and 5. So we have 2,000, 1 plus 0.03 divided by 12. And we're going to raise that to 12 times 5, which is the 60th power. And we get 2,323.23, and there's a 3 after the nearest penny, so we're going to just have 23 cents there. Okay, so let's switch to this tab. So we have our amount is 2,000. Let's see, what was it? 2,323 point, I believe, 23 cents. Let's just check that. Yep. Okay, cool. All right, let's look at another one. Sally invests $5,000 at Jimmy Bank, which offers her 2% interest compounded daily. How much interest does she earn after 3 years if she doesn't withdraw or deposit any more money? So first off, we're going to calculate the total amount that she has, and then we're going to subtract the initial investment to figure out her interest. So the total amount is going to be the principal, so $5,000 times 1 plus the interest rate is a decimal, 0.02, divided by its compounded daily, so there's 365 days in a year. And we're going to raise that to 365 times 3 years. Okay, so let's go over to our Desmos. So we got 5,000 times 1 plus 0.02 divided by 365. And we're raising that to the 365 times 3 power. Let's just make sure I got all that right. Yep, looks like it did. If I didn't, I'm sure someone will call me out in the comments. Okay, so we've got 5,309.17 cents for the total amount. So 5,309.17 cents. Now the interest is going to be that amount, and we're going to take off the principal. So we're going to do 5,309.17, and we're going to subtract 5,000, which is the initial amount invested. So the interest here is going to be 3,009.17. So it's just, you got to be careful on these problems to answer what's being asked of the question. So if you just calculated this, you'd be wrong, but you do have to subtract the principal amount to get the interest. Okay, let's look at this problem. So Jimmy invests $2,000 at Jimmy Bank, offering 3% simple interest annually. Sally invests the same amount for the same interest rate at Sally Bank, compounded annually. So we have simple versus compound interest. If neither Jimmy nor Sally withdraws or deposits any more money in their bank accounts, who will have more money in their bank account after 10 years? So first off, let's start by just calculating how much interest Jimmy earns. So he's going to do 2,000 principal times rate times time. So 2,000 times the interest rate is a decimal, 0.03 times 10. That's going to be 600. Okay, and then we're going to add that. So his total amount is going to be the initial amount invested, the 2,000, plus the 600. So that's going to be 2,600. Okay. Now we want to figure out, so that's for Jimmy. Okay, so Sally's amount, she has compound interest, so it's going to be 2,000 times 1 plus 0.03 over, it's only compounded annually, so one time per year, to the 1 times 10 power. So that's to the 10th power. All right, so let's go over to Desmos. So I'm going to delete these, delete all. So I'm going to do 2,000 times 1 plus 0.02 divided by 1. And we're going to raise that to the 10th power. I think, wait, did I get that right? Oh, it's 3% interest, so mess that up. 3% interest. So yes, Sally gets 2,687.83 cents. So 2,687 points. Let me just check that again. $0.83. And that's Sally. And as you can see here, Sally earns about $87 more, almost $88 more. So the compound interest wins in this particular case. Hopefully this video was helpful to you. If it was, please like and subscribe. Also, I'll leave a link to a blog post with these problems in it in the description in case you want to check that out, as well as links to my TeacherPay Teacher store and website if you want to support the channel in that way. Hopefully you enjoyed this video, and I hope to see you in the next one. Have a great day. Bye.